What's up? We have a numerical methods topic to introduce here. It's the Newton-Raphson method. And just when you thought there were not any more root finding methods, we have another one. So this method is indeed used to find the roots of equations, and that is where f of x equals 0. So it's where the function crosses the x-axis. And we have our formula here. It is x sub I plus 1 equals x sub I minus f of xi over f prime of xi. So at this point, in your mind as the student or the learner, you will either be given this formula, which is really nice, and you can just plug in the values as they're given. But if you are not given formulas, you either have the other options. You can either memorize this, or you can make the effort to understand where this formula comes from. And I would say, obviously, if you're in a hurry, everyone's been there, where you just want to memorize the formula and get out of there. So if that's you, then and you're in a hurry to just do the problems and practice this, then this video might not be too helpful. But if you really want to understand it, which I would recommend because it'll only take 5 or 10 minutes of your time, I encourage you to keep watching and try to understand this method. But it is always nice to know both to memorize this and also understand where it comes from. So let's get into what each of the variables are. They are pretty straightforward, but let's go through them. So x sub I plus 1, that is your new approximation. And x sub I is simply your initial value. Or, after a few iterations, it becomes your previous approximation. Okay? This is also, you should know what this means. F of xi plus 1, that's just your function evaluated at x sub I. This is also the height of the function at that point. F prime of xi, that is your slope of the function at xi. Okay, and your slope is also known as the rise over the run. And why am I showing you this? You'll see in just a second. So if your slope equals your rise over your run, what would your run be equal to? So if you solve for the run in terms of slope and rise, what will you get? Your run is equal to the rise over the slope, which is equal to f of xi over f prime of xi. Okay, oh wait a sec, this part right here looks awfully a lot similar to what we have in our function. So to get our new approximation each time with the Newton-Raphson method, we have x of I plus 1 equals x sub I minus f of xi over f prime of xi. Okay, so if we were to write this out in words, we could say the new approximation is equal to the old approximation plus the run. Okay, I just told you plus the run, so it's going to be your last value plus the run in either the positive or negative x direction. And you might be thinking at this point, why is there a negative sign? You just told me it's plus. But the negative sign can be explained. The negative sign is used to account for other sign changes. And what I mean by that is, if we look at an actual function, here if we look at an actual function, this will become pretty clear, or it should be clear. Alright, so this is just a function going through the x-axis. Right here we have our root, and what I want to look at is if you were to pick two initial guesses, so xi1 and xi2. And the reason I'm doing this is to show you what happens when you take initial guesses on either side of the root. What will happen with your new approximation. So at xi1 we have f of x is a positive value here, and you can also see that your slope is a negative value. And what happens at xi2? We have f of xi2 is a negative value, so a negative y value, and f prime of xi2 is also negative. It's a negative slope. Okay, so what I want you to see here is when you have your equation for the Newton-Raphson method and you want to find your new approximation, what is that equal to for each case? So xi1, we have xi1, so our new approximation is going to be equal to xi minus it's going to be minus a positive value over a negative value, which is the same as x sub I minus a negative value. Okay, and whenever you're subtracting a negative value, you'll get positive movement in the x direction, in the positive direction, which should make sense to you, because if we start at xi1, we would have to move in the positive x direction to get closer to our root. And if we look at xi2, we should see the same thing, except movement in the negative direction to get closer to our root. So let's verify that for ourselves. So xi2 will have xi minus a negative value over a negative value, which is the same as xi minus a positive value. So what happens this time? If you're subtracting a positive value, you will get movement in the negative direction. So this should make sense. So if we start at xi2, a point on the right-hand side of our root, we should get movement in the negative x direction to get closer and closer to our root. Okay, and for yourself, something I want to challenge you to do is we looked at a function that went from positive to negative, positive y values to negative y values, and it crossed the x-axis. So what I encourage you to do is look at a function just as we did here, but look at it going from the negative to positive values crossing the x-axis, and you'll see the same result. The sign, the negative sign here, is used to account for the other sign changes and tell you whether to go in the left or right hand x direction to get closer to this root. Alright, hopefully you did stick around and try to understand the Newton-Raphson method and how this formula works. And I really admire you for that. Good luck in your numerical method endeavors.